All right, this is a problem where we're going to use the central limit theorem in order to solve this. The population mean and standard deviation are given below. Find the required probability and determine whether the given sample mean would be considered unusual. For a sample of n equals 65, find the probability of a sample mean being less than 22.2 if mu equals 22 and sigma, the standard deviation, equals 1.17. The first part of the question simply states, for a sample of n equals 65, the probability of a sample mean being less than 22.2 if mu, the population mean, equals 22 and sigma, the population standard deviation, equals 1.17 is. And we're going to go ahead, as I said, and use the central limit theorem to calculate this. In order to use the central limit theorem, we have to determine if this particular problem falls within that realm. And we're going to look at the sample size. Since n is equal to 65, we know that we can use the central limit theorem since it is greater than or equal to a sample space or sample size of 30. Okay, and we also need to remember that this means that mu sub x bar, which is the mean of the sample means, is roughly equal to mu, the population mean. And mu right here is going to be 22. And that's going to be a key for us. And then we're going to talk about the standard deviation. Now, the standard deviation of the sample means also known as sigma sub x bar, is the standard deviation of the sample means and is roughly equal to sigma, the population mean. So that means that I'll be comparing that to sigma equals 1.17. We already know that our sample size is 65. So what we're going to do is we're going to go ahead and find the standard deviation for this particular layout. Remember that the standard deviation for a sample, given that we're using the central limit theorem, is going to be this. Sigma sub x bar will be equal to sigma over the square root of n. And what that does for me is simply allows me to take the sigma that we have in the problem already, which in this case is 1.17, and divide that by the square root of n, which in this case is 65, and that will be equal to 0.145. All right, now that we know that the mean of the mean of the sample means to be, we need to find our z-score. And we're going to use z is equal to x bar minus mu sub x bar all over sigma sub x bar, which can roughly be translated to x bar minus mu, which is the mean of the population, over sigma, which is the standard deviation of the population, divided by the square root of n. And that's going to look roughly like this. X bar is 22.2, mu is 22, sigma divided by the square root of n, which we just found, is 0.14. So therefore, plugging this into your calculator, 0.2 divided by 0.145 is equal to 1.38. That right there is the z-score that we want to be looking about, or looking at, I should say. So if the z-score is equal to 1.38, then the supposition, what is the probability of the sample mean being less than 22.2, is the key to solving this. And so the next thing that we do is use your z-table, okay, the standard normal distribution. And I want to find the following. So P is the probability of X bar less than 22.2 is going to be equal to the probability of Z less than 1.38. And now that we've done this, we want to go ahead and find Z is equal to 1.38 in the standard normal table. And to do that, we're going to need a standard normal table. Now 1.38, that's going to be a positive Z-score. So we're going to want to use the second, the second table that is found in your textbook. And that is simply going to be the following. So now that we found 1.38 as a z-score in the table, we find that the probability or the area under the curve is 0.9162. So we see that z is equal to 1.38, area of 0.9162. So the probability that my z-score, z is less than 1.38, is equal to 0.9162. And that equates to a probability that the mean x bar is less than 22.2 is equal to 0.9162. And that will be the answer that my stat lab is looking for. So right here in my stat lab, the question is for a sample of n equals 65, the probability of a sample mean being less than 22.2 if mu equals 22 and sigma equals 1.17 is 0.9162. The follow-up question to that is, would the sample mean be considered unusual? Well, the answer is the sample mean would not be considered unusual, because it has a probability that is greater than 5%. If you remember from the discussions in the textbook, it's only considered unusual if it's less than 5% or 0.05.